functions. Today we're going to look at the growth or decay aspect of exponential functions. So let's get down these notes here. Make sure you guys are writing down these notes. Everything I say, everything I write, make sure that you get it down. Linear functions. General equation, we see it as y equals typically mx plus b, but ax plus b is no different. It's the same thing, where a is your slope, typically m, a or m, and b is your y-intercept. All right, that's linear functions. And then function notation, f of x equals mx plus b. F of x just means y. The new function, exponential. The general equation is y equals ab to the x. And recall, variable is the exponent for an exponential function. So x is our exponent. And this is also part of our flippable that we saw before, but let's get down these notes again, where a stands for the initial value, or your starting amount. Okay. B is either your rate of growth, or it's your rate of decay. Okay, growth and decay. Recall when we do rate of growth, it's when b is greater than 1, which we'll see examples of what I mean here, and when b is less than 1. Okay, so rate of growth when b is greater than 1, decay is when b is less than 1. Get those notes down. And then x represents your time. The time given, for example, ex, the number of years. Okay, this is just an example. Say 4 years gone by, 4 would be your x value. Okay. So make sure you guys get all that down. Exponential functions are able to have both a positive or negative rate of change. And that makes sense. Positive or negative rate of change. A positive rate of change, that is called an exponential growth. So your positive rate of change, that is your exponential growth. And how do I figure out the b? It's saying to get b, aka in this equation, y equals abx. How do I get b, rate of change? It's 1 plus r. And we'll get into what r stands for. But for now, make sure you get 1 plus r. Okay. Negative rate of change, that is your exponential decay. And to get your b for exponential decay, recall what I said before in the previous videos. We always start at 1, and r is like our percent. So we always start at 1. If it's below 1, we know it's a decay. So it's 1 minus r. But if it's above 1, we know it's a growth. So 1 is always our testing point, basically in this case. Okay. And if this seems like a lot, don't worry. We're going to need a lot of work with it. At one time, this probably looked really confusing to you too, but now we know it like the back of our hand. Let's take a look at examples of graphs. So here, this graph, it's a linear function, but in specific, this graph is a positive sloped line. This is a positive sloped line. And why is that? Well, because it's increasing from left to right. Okay, so this is for linear functions. Now if we go down here, this graph, this is a graph of a negatively sloped line. right? Negatively sloped line here. Why is it negatively sloped? Well, because it's decreasing from left to right. We always look left to right, just like we're reading a book. So it's decreasing from left to right. Therefore, I know it's a negative slope. Let's take a look at exponential functions. So again, I always look left to right. Well, what's happening left to right? Starting over here, like I'm reading a book, going right, it's definitely decreasing. It decreases from left to right. So this would be a graph for an exponential decay. For this second box, I look left to right. Well, left to right, definitely increasing from here. So it increases from left to right. And this is a graph for an exponential growth. Okay? So you guys get that down. And I'm going to move on to the next page. Okay. Exponential growth or decay. What do each of these mean? Let's reiterate, because this is super important. It's probably why it's so huge on the paper. Any quantity that grows or decays by a fixed percent. Oh, there's that word, fixed percent. I don't know if it was day 1 or day 2, but percent always implies exponential. Or always implies multiplication, which is exponential. So, let's go back to text. Y equals ABX. Again, A stands for your initial value or your starting amount. Same thing. A stands for your initial value or your starting amount. B, that is your rate. And we always change the percent to a decimal. Okay? The rate, we always change the percent to a decimal. If there's two different B's I could get a growth or I could get a decay. If I get a growth and I want to figure out how I'm going to fill in my formula here, y equals ABX, this will seem kind of confusing at first, but bear with me. It's 1 plus your decimal, aka your percent, because we always change percents to decimals. And again, it has to be 1 plus because a growth is greater than 1. And we can also have a decay, where it's not 1 plus the decimal, it's 1 minus your decimal now. And again, decimal is just percent. We change the percent to a decimal. That way we can work with it and manipulate it. And then X is your time. For example, number of years. Okay, make sure you guys get all that down. And let's take a look at these two graphs here. All right, it's going again. It's giving me, this situation is called an exponential blank. Well, again, always look left to right. I definitely know this is not a linear function. This is not a straight line. It's decreasing exponentially fast. So I look left to right, it's decreasing. This situation is called an exponential decay. And that means that my B value would be less than 1. My B value would be less than 1 because it's a decay. Look at this one, going from left to right, definitely increasing. So this is an exponential growth. And that means that my B value is greater than 1. Okay. go on to the final page of this lesson. Okay, identify the following equations as either linear or exponential. Let's do it. This first one is definitely going to be exponential. And why is it going to be exponential? Well, it's 3 to the x plus 2. Okay, 3 to the x plus 2, that tells me the x as the exponent has to be exponential. Okay. Exponential because of that x. 2y equals negative 5x plus 1, linear. Y equals 7. Linear or exponential? Definitely linear. This is hoi. This would be a horizontal line at 7. So this is linear. And here's C. Whoa. Exponent of x. Definitely exponential. Okay. For questions 2 through 5, 3 parts. Part A, state whether the function is a growth or a decay. In other words, is b greater than 1 or is b less than 1? State the initial value, that's your a in your equation. And then state the rate of growth or decay. What is your actual b value? Okay, well, let's see. We know that exponential functions always follow y equals a b to the x. So let's look at number 2 here. It's following this form right here. So here's my y. My a, that is my initial value. Okay? So my initial value, in this case, is 100. Now, it says 0.75. Right? 0.75. Well, is that greater than 1 or is it less than 1? 0.75 is less than 1, which means that's a decay. Decay because b is less than 1. And now I want to figure out what is the rate of growth or the rate of decay for part C. Well, again, we always start at the number 1. And what's the difference between 1 and 0.75? How do I get from 0.75 to 1? Well, let's just subtract the two. 1 minus 0.75. That gives me 0.25. And what is 0.25 as a percent? That's 25%. Okay? So there we go. We did all 3 parts. Let's try this next one. P of n equals 40, 1.80 to the n power. Okay, well again, the first piece is like my a value. This is my initial value. Right? 40 is my initial value. That's what I start with. Here I have 1.80. Is that growth or decay? Is it greater than 1? Less than 1? This is a growth. And why is it a growth, you might ask? Because b is greater than 1. In other words, this is b. 1.80 is b. And b is greater than 1. What is the rate of growth? Well, again, how do I get from 1 to 1.80? I just subtract the 2. I do 1.80 minus 1. That gives me 0.8. which as a percent is 80%. So this is an 80% growth rate, which is pretty high. Okay, number 4. Let's use green. T of x equals 10,000 times 1.02x. All right, well, 10,000 is my initial value. Is my initial value. This 1.02, is this growth or decay? This is growth because b is greater than 1. And what is that growth rate or decay rate? Well, again, how far away is 1.02 from 1? I subtract the 2. Bigger number goes first. 1.02 minus 1 equals 0.02, which as a percent is 2%, not 20. Okay. And last but not least, number 5 here equals 50 times 1/2 to the n. Okay, well, 50 initial value. 1/2 to the n. Huh. Is that greater than 1 or less than 1? Well, 1/2, as we should know, is just 0.50. So is 0.50 greater than 1, less than 1? It's less than 1, so it is a decay, because b is less than 1. And I want to find what is this actual decay rate, so I subtract 0.5 from 1. So my decay rate is 0.5, which as a percent is 50%. Okay? Not too terrible. Steps for writing and solving functions. Well, first thing, obviously, identify the type of function. Are we working with linear, or are we working with exponential? If it's exponential, first thing, determine A. Determine your initial amount, your starting number. What is it? And then determine B. What is your growth, or what is your decay? Let's take a look at some examples. Number 6. A tennis tournament has 128 competitors. 128 competitors. Well, if you look and think about it, it's starting with 128 competitors, right? That is going to be your starting value. That's going to be your A in this case, because it's your starting number. Then it goes to half the competitors are eliminated each round. Half of the competitors are eliminated each round. So, do you think that's a growth or a decay? That is definitely a decay because they're being eliminated. Decay by what, though? What's the number? Well, it's going to be 50% because they're losing half the competitors each round. Write a function to represent the number of competitors that will be left after X number of rounds. This is your time, the X. And then determine how many players will be left after 5 rounds. Okay. Well, again, we know that this is our A, our starting value. So, if I know it follows the form of y equals AB to the x, I know my A is 128, so y equals 128. What is my B? I know it's going to be a decay by 0.5, right? decay by 0.5. So now I'm going to follow this piece here. Just like we did up here, right? We did 1 minus 0.75, 1.8 minus 1, 1.02 minus 1. Well, here it's going to be, for my b, 1 minus, what is 50% as a decimal? 0.5. So it'll be 1 minus 0.5 to the x. So this is my function now. This is the function that represents the number of competitors that will be left after x rounds. And now I want to answer how many players will be left after 5 rounds. So all I want to do is substitute in for x with 5. So let's do y equals 128. 1 minus 0.5 is just 0.5, 0, to the 5th power. Now, with your calculators, you will plug this in exactly as you see it. You're not going to do this first. You're not going to do the multiplication first. You are going to plug this in exactly as it shows on your paper, and you will get y equals 4, which means 4 players will be left after 5 rounds. Okay? All right, number 7. A 3-bedroom house in Burbville was purchased for $199,000. Kind of cheap. This is our starting value, $199,000. That is my A. If the housing prices are expected to increase by 1.5%, expected to increase by 1.5%. Write a function that models the price of the house in t years. We're going to stick with y, but it gave us everything we need. Right? It gave me my A, gave me my initial value, and it gave me whether I'm working with growth or decay. Hopefully we see, since it's an increase, it is a growth of 1.8%, which written as a decimal is 0.018. We just take 1.8 and divide it by 100 to get our decimal. Okay, let's fill this one in. Again, it's going to follow the form y equals ab to the x. I know my A is going to be 190,000. My B, 0.018. 0.018. Well, since it's a growth, I'm following this now. It's going to be 1 plus 0.018. 1 plus 0.018 to the x power. Because it's a growth, again, we always start with 1. Let's not forget this. If it's growth, it's a plus. If it's decay, it's a minus whatever our percent is. And it wants to know the price of the house in 6 years. This is my x value. So let's use our equation. Y equals 190,000. 1 plus 0.018 is 1.018, all to the 6th power. You will plug that into the calculator exactly as you see it, and we should get that y is equal to $211,000, 465 and 86 cents. So after 6 years, this is the new price of the house when it started at 190,000, which is actually pretty realistic. It would probably be worth more money, actually. But who knows? Last one, number 8. Jonathan makes a weekly allowance of $25. He also makes $9.50 an hour at his job. Write a function for the amount of money he makes each week based on the amount of hours each he works. And how much will he make if he works 25 hours? Hopefully, we see this is not exponential, but this is linear. And you guys can set this up, and you should be able to with ease. Y equals 950x plus 25. I'm going to let my x equal, I don't know, what's x going to equal here? How much will I make if he works? Let x equal hours worked. And I want to know if he works 25 hours, y is equal to 9.5 times 25 plus 25. So he would make $262.50. Okay, and that is the end of day